Hello and welcome to this walkthrough of a challenging A2 redox exam question. The reason it's a bit tricky is it's got several things going on in sequence. First of all, you have to deduce a redox half equation from the other half equation and the overall redox equation. It's a bit different from the way you'd see it in textbooks. Secondly, there's a scaling factor in a redox titration, which always is something people forget to do. And thirdly, you have to deal with concentration as grams per decimetre cubed. There's quite a lot going on. So let's take it step by step. Firstly, let's think about reading the question. So the half equation for MnO4 minus reduction is provided. The KMnO4 aqueous is used under acidic conditions. The H2O2 is a reducing agent, and the overall equation is provided. So what do these things mean? Firstly, the half equation allows the number of electrons gained or lost to be worked out. If you know that KMnO4 aqueous is used under acidic conditions, it means you've got a supply of H+, so you can play around with that and use it to balance charges, etc. Usually H2O2 is an oxidizing agent, but this time it's losing electrons. So if we're working out a half equation with the oxidation of H2O2, that means it's losing electrons. If we've got the overall equation, that means the mole ratios of the reducing agent to the oxidizing agent are given. In other words, you have 2 moles of MnO4, just here, to 5 moles of H2O2. That allows us to write out what it is we have to do. What's missing is this part here, second equation. Normally, they give us the 2 equations, we have to put them together to get the bottom part. They've given us the bottom part, so it's a little bit different this time. So, looking at the mole ratios in the overall equation, you can see that you have to double the mole ratios of the reduction half equation to get those moles. So doing that now allows us to work out you need to cancel 4H plus somewhere too. As we reduce, we are starting with 10 electrons. So if you double everything, you can see you've got 16H plus. I've left that out of the first doubling, so I can now relate that to the fact that we have a difference of 6H plus. So each H2O2 must lose 2 electrons, so 5 of them lose 10 electrons. Why is that? Because you've got 5 H2O2s and you've got 10 electrons you're having to deal with. So that gives us this other equation. This is the oxidation half equation, but they want the simplest whole number ratio. So let's first of all cancel everything out and double check that putting all that together would give us the overall equation that they give us. So yeah, that matches what they provided for us, so we know we're on the right track. So remembering that 5 H2O2s loses 10 electrons and 10 H pluses, we divide by 5 to get the lowest whole number ratio, like so. Next question is a redox titration. First of all, let's visualize the process. Student diluted 25 centimeters cubed with water and made the solution up to 250. Then the student titrated that with 0.200 moles per decimeter cubed KMnO4. Okay, so there's the burette where it goes into, and then the average titer would have been 23.45. So it's a data moles equation moles answer type calculation. So put in the data that we're given for MnO4, which allows us to work out the moles as 4.69 times 10 to the minus 4. Mole ratio is 2 to 5 from the equation previously, so that means we multiply the MnO4 minus moles times 5 over 2, giving us 1.1725 times 10 to the minus 3. So that means that you have that number of moles in 25 centimeters cubed. Remembering that that came from 250 centimeters cubed, that means you multiply it up by 10. And that means you have that number of moles in the original 25 centimeters cubed, in the undiluted version. So if you have that amount of moles, that would mean 0.469 moles per decimeter cubed. Because you've got 1000 centimeters cubed in a decimeter cubed. So if we take grams per decimeter cubed, the moles per decimeter cubed times the molar mass of H2O2, and multiply it up, that gives us 15.946 grams per decimeter cubed. Remembering V equals 24N at RTP, the number of moles of oxygen is the same as the number of moles of H2O2. So therefore, pushing that into the V equals 24N equation, that gives us 0.02814 decimeters cubed. Thanks for listening. Until next time, see you soon.